Okay, things for the final to make sure of. Number one, you need to bring several things. What do you think I think is the most important thing to bring? Calculator, but very close behind that, the note card, okay? So listen, a compass would be like my least important thing, but you do need it, yes.
You need it for this semester?
You're doing, okay, guys, I'm about to tell you all of this, if you would just listen. You need to bring with you next week, Wednesday at 8:30, because that's when our final is. You need to, next Wednesday, 8:30. Okay, so here's what you're bringing, okay? Number one, you need a calculator. Please don't show up to my final without it. If you do, you have to rent one for $5 during final exams. Wow. You don't want to do that. Bring your calculator, okay? And that's a campus-wide policy. Like the entire math department, the library, everybody rents them for $5. If, by the way, you don't have one, the library does have some that you can rent. So don't forget that, because if you can't find me, there's a library. Theirs is $5 too. Okay, so calculator. Second thing that's super important for you to bring is you must bring that 4x6 note card, because it is going to be a terrible final exam if you don't have it, okay? We did so many formulas this semester. First semester, you didn't need it, not as many formulas. This semester, like 30 different formulas in 3 of the chapters, on top of just a whole lot of other concepts and theorems that I would like you to have access to. So make a good note card, 4x6, both sides. You may write whatever you want on it. You may write sample problems on it if that would be helpful to you. I'm fine with that, but do it, okay? So calculator and 4x6, those are the 2 most important things. You also need pencils. You also need a protractor and a compass, because you do a rotation. That's the only thing you need tools for, is the rotation, okay? And we do one of those on here, so you'll get plenty of review with it. What we are going to do right now is just go through any of these questions that you have, 1 through 9, and then you'll have a chance to start in on tomorrow's assignment, and I will walk around and help you out with any questions you have from that. So, but 1 through 9, is there anything you have questions about? Sam?
Can you scroll down? I can't remember that one. 7.
7's probably the one that people do wrong the most on this little chunk. Remember, this was geometric mean. When you have a set of 3 right triangles like this, where you draw the altitude of the biggest triangle in, okay, that would be this line here is your altitude, right? Oop. This one here is the altitude, right? So when you draw that altitude in, what it does is it cuts this into 3 triangles that are similar, meaning they are proportional, okay? Do you remember how we often set this up?
Draw 3 triangles.
You draw 3 triangles. So just draw your 3 triangles all with the same orientation. So you have shorter leg, longer leg, hypotenuse, and shorter leg, longer leg, hypotenuse, and shorter leg, longer leg. How are these colors for you, Sam?
Oh, they're good.
Hypotenuse. Okay, so if this is your setup and we want to find all of the pieces to these 3 triangles, let's start with the red. Okay, that's this triangle here, your smallest triangle. What is the shortest leg
3.
on that? That would be a 3. What's your longer leg?
Z.
That's the Z. And then the hypotenuse, keep in mind, hypotenuse is always across from the right angle. So the hypotenuse here would be Y. Okay. Then the blue triangle, that's this triangle. What is your shorter leg?
Z.
That would be Z. The longer leg is 12. and then the hypotenuse, this is your right angle here, so your hypotenuse would be across from that is the x. So then you look at the big triangle, which is the purple. You're welcome to color code all you want on this final, by the way. What? You may bring colored pencils, sure. Don't use them to fill in your answer, but you may use them to solve. What's your shorter leg right here? In the purple triangle. The biggest triangle. It would be Y, okay? This is usually the triangle people make mistakes on, just because this line in the middle, I feel like, throws everyone off. So X would be your longer leg. And what's your hypotenuse? 15. Thank you. So just make sure with hypotenuse that you add those two together, okay? So now you're set up. When you go to solve this, you need to find which two triangles you're using for each variable that's missing. So if I'm going to solve for x, I have an x here, and I have an x here. What corresponds to my squared x then? Did you say something? 15, right. Yeah, you're right. So it would be x and 15. What corresponds to the circled x?
12.
The 12. So if you set this up, remember this is geometric mean, 12 over x, corresponding parts, equals x over 15. Is it wrong if I set it up x over 15 equals 12 over x? No. You just have to match up the corresponding parts, okay? So you would cross multiply this. You get x squared equals 12 times 15 is 180. Do you remember what you have to do at this point? We don't want decimal answers. You're going to square root it, but you don't plug it in. You put it into simplest radical, okay? So 180, I want to say it's 36. Okay, so if we do the square root of 36 and the square root of 5, what's your answer? 6 rad 5. Right? Simplest radical form. Square root of 36 is 6. Okay? Don't be over it. We're just starting. Okay, let's do y. What two triangles are you using for y? Shh. Hey. Quit talking. Pay attention. Right. So you have a y here, and you have a y here. Okay? So this y, if we're using these two triangles, that y is the hypotenuse, which would correspond to the hypotenuse. And this y is the shorter leg, which would correspond to the shorter leg. So your proportion would be 3 over y equals y over 15. So then you cross multiply that, y squared equals 45, and then take the square root. What perfect square goes into 45? 9. So 9 and 5, which would make it 3 rad 5. Okay, so that's your y. And then for z, you're using the first two triangles. So you have a z here. That would correspond to a 12 here. And you have a z here. That would correspond to a 3 here. So it's 3 over z equals z over 12. So you get z squared, z times z, and then 3 times 12 is 36. Take the square root of that. If you can actually square root it, then you do. Don't try to break that into two different radicals, because the square root of 36 is 6. So that would be your 3 answers there. Any questions on that?
No, not that one, but
Yeah.
another one.
Yeah, which one?
Number 9.
Okay, so here's the deal with number 9. We learned a theorem. It was called the side splitter theorem. Do you remember that one? Which basically says the two sides that are on the same side of the triangle are proportional to the two sides that are on a different side of the triangle. So basically what you can do with this one is put a division bar here, put a division bar here, and set them equal to each other, and that's your proportion, right? So the two that are on the same line, So 12 minus x over x plus 3 would equal 6 over 4. Okay, so if we solve this one, cross multiply it, we get 4 times 12 minus x equals 6 times x plus 3. Okay, distribute that, so you get 48 minus 4x equals 6x plus 18. Solve that, so you get 10x equals 30. Sorry, I kind of ran out of room. So add your 4x, you get 10x. Subtract your 18, you get 30. And then divide by 10, so x is 3. Okay, so that's how you would solve for x in that problem. Y is different. If you notice in these two, the top set of numbers, so this and this, those are not sides of a triangle. They're parts of sides of a triangle, right? But they're not entire sides of a triangle. But when you look at the y and the 9, those are sides of your triangle. Sorry, let me get this stuff out of here. So the way you need to do this one is, because you're dealing with an entire side of a triangle and it's not where the parallel lines are splitting, you're using entire triangles here. Okay, so if you think of this as, for instance, this triangle right here. In that triangle, which does not look anything like that. Okay, in that triangle you have a 4 and you have a 9. Don't worry about the x plus 3, that's just more work, we don't need it. But in the big triangle, in this triangle, you have what as this side up top? That's y. What is this side? It's 10. Make sure you add those together, okay? So now with this setup, your triangles are still proportional here. So we're gonna say 9 over y equals 4 over 10. So 9 over y equals 4 over 10, and then you cross multiply it. So 4y equals 90, and then divide by 4. Okay, which is what, 22.5? Sorry, this is very disjointed. 22.5. Okay. Questions on that? All right, what's next? Other questions? We did okay with 1 and 2, setting things proportional, a lot like what we were just doing, right? Oops. How about, what were the similarity theorems that were potential theorems for 3 through 6? What were the 3? AA similarity, SSS similarity, and SAS similarity. So you might just want to write those down on your little cheat sheet. Really, anything you don't know how to do on here, you want to write on your little note card. If you see like an ASA, it doesn't exist, right? ASA worked for congruence. Chapter 7, we were talking similarity. So these are the only 3 that are going to work for those triangle similarity postulates. Anything else you want to see? Actually, let's just quickly talk through this. For number 3, when you have parallel lines, what often shows up? Alternate interior angles, right? So I know right now that this angle, angle B and angle C, are congruent, okay? Or you could say we have vertical angles, or you could say we have alternate interiors here as well. You don't need all 3 because of the third angles theorem. You only need 2 sets of angles, but this would be AA similarity for that, okay? And you will have to name the triangles that are similar. So make sure you're matching up the corresponding parts. So if I said like triangle BEA, what triangle is that similar to? CED, right? 1 arc to 2 arcs to 3 arcs would be 1 to 2 to 3. So CED by AA similarity. Okay, so make sure you're telling me the postulate or theorem, the two triangles that are similar, and then if there is a ratio involved, give me the ratio with it as well. With angles, there's no ratio involved, but like with this one, right? This was 5 to 10 or 14 to 28, so that's a 1 to 2 or a 2 to 1, depending on the order you named it in. If I named it bigger to smaller, then it would be 2 to 1. Okay. Any other questions? Okay, so that is 1 through 9. Your next batch is 10 through 21, did you say, Sia? 21. So 10 through 21, I'm going to let you get started on that right now. We have 20 minutes. That's a lot of time. Use that time. I will walk around and help you out as much as I can. 7th period, I'll help you out tomorrow.